Well, good morning, everyone. Our goal today is to get 7.3 finished, so I want to go over as many questions as we can. This one's kind of weird, so I'll start off with this one. The integral from 0 to a of a squared plus x squared raised to the power of 3/2. So it's got a couple of weird stuff. Doesn't have a square root, it has a 3/2, and doesn't have numbers, it has a's, and has a start and finish limit integration. So you put that whole set together, quite a few things that are a little bit different. Well, first things first, a squared plus x squared. Well, that's actually kind of nice because it looks the way it's meant to. So we now have the guy we're going to use. So I hope that step is getting a little bit more obvious, right? What is the x sub to use? So when it's a squared plus x squared, you use this fella. Now, if you differentiate this fella with respect to theta, you get a secant squared theta. And when you do the crossover, you're finished. So we spoke about this yesterday. You only have 3 lines rather than the typical 4 that you'd have in a U sub. So let's see what this fella becomes. It's the integral. Forget about these because we're going to change over to thetas. We're going to be a 1. That guy squared plus x squared. So what's that going to be? That guy squared plus that guy squared, 3/2, followed by an a secant squared theta, d theta. I'm going to put the a secant squared theta d theta on the top. That way we can focus on this guy. A squared plus a squared tan squared. Any ideas about how I could rewrite that to get it nicer eventually, really nice? A squared plus a squared tan squared.
Pull out the a.
Okay, so we'll pull out an a squared. Do you recognize 1 plus tan squared?
Secant squared.
Right. So what we've got here is a squared secant squared theta, all raised to the power of 3/2. I'm going to go this way. A squared raised to the power of 3/2. Basically, that times that gets you a cubed. Secant squared raised to the power of 3/2 gets me secant cubed. Are you happy about that? Now, what we got here is a bit of a cancelling and a lot of this guy cancelling. Now, it looks like we're going to have 1 over a squared secant theta d theta. So far, so good. Now, here's a little thing that you might have missed. That actually is not as difficult to do as you think. If you realize that 1 over secant can be written in a much nicer form.
Cosine?
Yeah. So what you now have is that fella. Would you agree that's very easy to integrate? I don't need to do U subs, really don't need to do much. In fact, that's the answer, right? Integrate a cosine, you get a sine. Now, we'll return back to this guy, because this guy is going to become this guy. So I'm going to put my theta here. This is going to be opposite. The side's going to be called the adjacent. The side is going to be called the hypotenuse. And the tangent is opposite over adjacent. So this is x, and this is a. And by Pythagoras, this will be x squared plus a squared, which is pretty much that guy. Now, we know what the answer is from here. So I just need to find out what sine theta is. So it's going to be 1 over a squared times the sine of theta, which is what, x over this guy, opposite over hypotenuse. Now, normally that would finish with a plus c, right? But in this question, it's going to go from 0 to a. So we're going to go x equals 0 to x equals a. So I have 1 over a squared times an a over the square root of a squared plus a squared. Take away basically nothing. Now we want to make this pretty. How about cancelling one of those a's? A squared plus a squared is 2a squared. Agreed? Is there anything else I can do to this to make it look even nicer? The square root of 2a squared.
You can take out a, 2, a squared.
Okay, so by that you mean the square root of 2 times the square root of a squared, so it's the square root of 2a.
Yep.
Right. So what do we have is we have an a times square root of 2a, which ends up being, I think I'll put the a squares at the front, they just look nicer. There's your answer. Are we good? Now, I'm not doing question 6, but question 6 is not that different from 5. It really isn't. Okay, I'm going to move that if we're good. Are we good? Right. Next fellow we're going to look at is a version of 7. It's going to be the integral from 0 to 4 dt over the square root of 16 plus t squared. I guess I should call this a t sub because it's not x's anymore, but that's really cosmetic. 16 plus t squared. What do you use in that case as your substitution?
Tan theta.
Okay. So it's the same one as before. Differentiate t with respect to theta. We get 4 secant square theta. Do the crossover, and we get 4 secant square theta d theta. And we are finished. Well, we're finished that. So it's going to be the integral of the square root of 16 plus this guy squared. And on the top, this guy. That's fair. Okay. 16 plus 16 tan squared. Is it not 16 secant squared? If we skip a lot of lines. So square root 16 secant squared. That becomes 4 secant squared on the top and 4 secant on the bottom. And that becomes secant theta. Agreed? And then you use this, that the integral of secant is this guy, because we're told it is. So it's going to be the natural log of secant theta plus tan theta. I'm just using the fact the integral of a secant is this. Standard integral. So what am I going to do? I'm going to dot, dot, dot this. Won't we take this guy, build our triangle? Yeah, we're theta there. Won't that allow us to figure out what that guy and that guy are in terms of t? Won't you then do t equals 0 and t equals 4? And about 10 minutes later, you get a number. It's probably a little quick. Anything you want to talk about before I skip by my dot, dot, dots?
I think I have a question back to question 5.
Okay.
So when we integrate cosine theta times 1 over a squared, all that should be to reference of theta, right?
Yes.
So do we just do nothing with 1 over a squared, even though it's a different?
It's a multiple. It's just like 5 cosines. 1 over a squared is not anything special. It's treated as a constant. So it's not like you're going to do a e to the -2 and do some power rule or some integration by parts or anything like that. And the reason you're not going to do that is that this doesn't have theta in it. It has a in it. And if you ain't theta, you're a constant.
Okay, I guess. Okay, I think
Right.
so.
Yeah, like if I said to you b times cosine, let's show you. Let me see it. Here's some examples of the same situation, right? If I said, what's the integral of that? We'd all say sine theta, right? If I said to you, 3 of them, you'd say 3 sine theta, right? Suppose I said b.
It would
Well,
just
you
be,
treat it.
yeah, b sine theta. Okay.
Suppose I said b squared. Or, for that matter, 1 over b squared. That's what I mean when I say we treat it as a constant, right? We treat it like it was a 3.
Okay.
Okay.
Thank you.
You're welcome. Any other questions? We good?
I have a question with number
Yes.
7.
Here we go.
Just a little. I was trying to follow along, but I still got. I was a little behind. I'm trying to figure out how you got to the ln of secant theta plus.
This here,
Yeah.
the integral of secant theta is known to be equal to that. And I wrote this
okay.
down here. So it's
Okay.
just like, what we call them standard integrals. Very often I just say, I've got a good memory, right? That's just the ones that you memorize, right? Well, you probably won't memorize that one, but you'll probably have a piece of paper with this guy written on it, right? And you'll use it.
Yeah.
Right, where are we? Okay, we got 8 coming up, I guess. This one is the integral of x squared take away 16 over x cubed with respect to x. So we're back to our usual kind of x's again. Okay, who are we going to start with as my x sub? Because this time it is an x sub.
For secant of theta.
Okay, so we're using number 3. 4 because of the 16. Now you differentiate x with respect to theta, 4 secant becomes 4 secant tan, because the derivative of secant is secant tan. Then you do the crossover, and dx becomes 4 secant theta tan theta d theta. And that's that bit done. So far, so good. Now let's do everybody getting fixed. X squared minus 16 becomes 16 secant squared, take away 16. X cubed basically becomes 4 cubed secant cubed. And dx becomes one more lot of 4 secant tan d theta. Really crushed that. Okay. Let's get this guy fixed in one go. 16 secant squared, take away 16. There's almost like a theme in these, isn't there? What does 16 secant squared take away 16 end up being?
Tan squared, 16 tan squared.
And doesn't 16 tan squared get me 4 tan? I'm trying to cut out lines now. Are you comfortable where that turned into that and how it happened? Because most of it was done in my head. Right, we verbalized it. This fella is 16 tan squared. The square root of 16 tan squared is 4 tan. I'll just write the other pieces next to it now. We've still got that guy. We have d theta. And on the bottom, we've got this guy. Okay, time for some carnage. Time for things to be killed off. Well, as much as we can. Won't that 4 and that 4 kill off 2 of these and you'll be left with a 4? Won't this secant kill off one of these and you'll be left with a secant squared? So let's see what we got left. On the top, we got this guy. And on the bottom, we got this guy. Now, there are lots of different ways you might approach this, but there's only actually one way that I can see in my brain that's actually going to get me anywhere useful. And that's one of the challenges and the fun of trig integration, is that they're not all the same. You know, there's always little nuances and weird combinations. Any idea how this thing could be solved?
If you divide tan by secant, don't you get sine?
Ah, yes, you do. And that's the way I'm going. I won't say it that way, but that's exactly what I'm going for. So here goes. Tan squared is going to be written as this guy. And 4 secant squared is going to be written like this guy. Won't these cos squares cancel out? Which means that I now have 1/4 sine squared theta d theta. Now, I might not have said it the way you were talking about, James, but isn't that the final result? Good. Not great yet, because we still don't know how to get the integral. But I think we've seen a sine squared before, and we know how to tackle sine squares, don't we? Would you be turning the sine squared into that's going to make this thing integratable, if there is such a word? This guy has to be turned into something.
The half angle identity.
Yeah.
Yeah, that one again. So it's 1/2, oh, sorry, it's 1/4 of 1/2 1 minus the cosine of 2 theta d theta, which ends up being, I'll pull it outside, 1/8 This guy. I'll take this just a little bit further before I do the dot, dot, dot thing. 1 becomes theta. And if you integrate a cosine, you get a sine. So if you integrate a cosine to theta, you get a half sine theta, and it's still negative. So that is the answer as far as theta is concerned. What we now need to do is convert it back to the original x's. And that gets done by using the original x sum, building a right angle triangle, and using that right angle triangle to do what we need. Now, if you divide both sides by 4, you get that. Now, I don't like secants or cosecants or tangents, or, well, I don't mind tangents actually, but I don't like cotangents. That is correct, but I am going to do an equivalent. If secant is x over 4, won't cosine be 4 over x? And in my brain, that just works better. Because I can use SOHCAHTOA. And according to SOHCAHTOA, it's adjacent over hypotenuse, right? So we are looking at an adjacent of 4 and a hypotenuse of x, which means that the third missing side is going to be x squared take away 16. Why is this square root x squared minus 16 a good indicator that I've probably been doing it correctly?
Because you see it at the start of the problem.
If you do this fella and it ends up being the square root of x squared plus 16, or the square root of 16 minus x squared, which is the reversed order. If you end up with the third side being that, that is normally a red flag for, oh sugar, I've probably done a mistake way up here. And you know, if you do a mistake way up here, you might as well just start again, right? Because you can't really fix it, there's too much going wrong. So from this, we can get anything I need. Well, I still have to work on it. If I want to get theta, which I do, won't theta just be the inverse cosine of 4 over x? So that's that bit. What about, how am I going to get that guy from this triangle? Well, don't we have to keep using stuff? Can you see this stuff? That the sine of 2 theta is 2 times the sine of theta cosine of theta. Now I want to know negative a half of that. So it's negative a half of that, which means it's that guy. And then you replace those two guys and dot, 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 you know, the question's over. So there's a heck of a lot, as always, a heck of a lot of stuff happening. Anything about that one? Okay, works. Oh, side issue. Where's that damn thing gone? That is theta. If I use this line, won't theta be the inverse secant of x over 4? Those are exactly the same thing, just two different versions. And who knows what WebAssign's looking for. I think WebAssign's probably going to look for the other one, whatever the other one is. So if you write the first one, they're looking for the second, probably, with my luck there. Yeah, what we got? 9. Square root of 4 plus x squared over x dx. I mean, if there's any saving grace in this, isn't it at least it's a process that you follow pretty much the same way all the time? So according to what we've talked about, isn't the first process, pick the right x up. Which one uses that?
A10.
Yeah, so we're going to use 2 tan. Correct. Differentiate with respect to theta gets you 2 secant square theta. Dx gets you 2 secant square theta d theta. Nothing particularly exciting going on there. 4 plus x squared becomes 4 plus 4 tan squareds. The dx becomes 2 secant squareds. And the x in the bottom becomes 2 tan theta. Okay, let's cut some lines of work in it. What will 4 plus 4 tan squared theta look like?
2 secant theta.
Right, and square root of that is 2 secants then. So that whole thing becomes a 2 secant. Next door, there's going to be a 2 secant squared. On the bottom, there's going to be a 2 tan. Not looking too good here, but at least one of the 2's cancel. And it looks like we have 2 secant cubed theta over tan theta d theta. You never know what you're going to get until you open the box, and this is what we found inside. Probably going to be where the fun starts. Any suggestions? Well, we could just decide not to do it, but I'm not thinking that's a good suggestion.
Can you turn both of them into sines and cosines and cancel out some?
See what happens. Yeah, that would be my strategy. If I don't see an obvious use of, that would be my next go-to strategy. I normally look at it and I have a kind of hierarchy. I try and say, is there a nice identity, like sine squared, can I do that? That's probably not going to happen, right? And then I think, is there a u sub out there? And nah, nothing obvious, so I'll skip that one. So my go-to kind of plan C is turn everything into sines and cosines. So that becomes 2 over cosine cubed theta. That's the top guy, put a little bracket around him. And the bottom guy is a sine theta over a cosine theta. Do that. So far, so good. I don't know how you do this. I'll do it over here. Can you imagine I had 2 cosine cubed times a cosine over a sine? You agree? And that cancels out with that. And I'm now looking at 2 sine theta cos cube theta d theta.
Cosine squared.
Yeah, cosine squared.
Oh, thank you. That's actually quite important. So I'm looking at that and I'm thinking, what did they do? Interesting. I'm looking at this one and I'm thinking, how on earth am I going to get out of this hole?
Can't cosine squared be written as like 1 like sine squared minus 1?
1 minus sine
minus
squared?
Yeah, 1
Yeah.
minus sine squared.
Yeah, it can, but I'm not sure that would help. But keep thinking. I like your thinking.
Or could we use the half angle rule for cos squared?
Could
I looked
be
at this guy and everything I can think of isn't going to work. And so I've figured out the solution, but I got a hint. This guy is not a good use up because I need a cosine, right? And I could fight my way through that, but if I did that, I'd have to use partial fractions, which happens next section. So I know that's not a star. I could use u, right? Meaning cosine. If I did that, it would generate a sine, which would make this guy wrong. And that ends up being a partial fraction. So the only way I could do this would be using a technique we don't know. So if I go back a step to when we were here, which is this guy, and I'm going to separate out this thing. Like that guy. And then I'm going to do that guy. To which you're probably saying, so what is going to happen next? Well, this whole mess is equal to, and I'm just looking at the screen here because I won't remember this either. It's going to be cosecant plus secant tan d theta. And how did that happen? I have no idea because I went and I looked and it looks like WebAssign generated a random question where some human better than me knows that this is that. Now it must be true, but I don't know. So basically that is telling me question 9 should never have been given to you, or at least the combination that WebAssign generated for me. Have you ever done a WebAssign question where if the numbers come out one way is quite nice, and then someone else got a different combination of numbers and it just went weird? I suspect that one of these, that guy there, if you change its power, well, probably not here, but the original guy over here, if you changed its power, would come out. So number 9 is going to get killed after I leave this room, right? I may actually beat it up a few times before I kill it, because I think that's a ridiculous question to give anybody. You should be able to at least fight your way through the math, right? You can't just say, and I wouldn't be surprised if they did it, that you go to Mathematica and you just type something in and say, Mathematica, can you make this into something else, please? And then you go and do it. So that gives us just enough time to do the last question, which I do know works, because I've done this one before. Okay, since it's the last one, hopefully things will go relatively nice. Right, tell me who the X sub's going to be. One, two, or three? Who's the X sub going to be?
1.
So that, right, now, that we did yesterday, didn't we? And we said, okay, according to 1, it's going to be something sine theta. And I said, look, it's not going to be 5, right? And it's not going to be 3, but it's going to be like a bit of A and a little bit of B, right? So who do you use?
Isn't it, wouldn't it be 3/5?
It is. 9/25 becomes 3/5, right? 9 is 3, 25 is 5. So if that was 16 and this was 100 or something, wouldn't you do whatever the square root of 16 over 100 would be and tidy it up? Now that's the first roadblock, figuring that out. Now, side issue, you want to see where that comes from at least once in your life. So here goes. That's no good. Don't I need that shape, right? In other words, I need one of these. So what you do is you pull out 25 as a common factor, and that becomes 9/25 take away x squared. Now, the 25 you could pull out, so it's not really there anymore. Can you see that that's your a squared, which means your a is now the 3/5 that we were talking about? Is that's the math behind why it's 3/5. Now let's return back to our question. I don't care, 3/5 is nothing really. We've done worse. So if you differentiate with respect to theta, you'll get 3/5 cosines. And if you do the crossover, so what do we get? We have the integral of x squared, which is 3/5 sine theta squared, over the square root of 9, take away 25, 3/5 sine theta squared, times this guy, which is yet another 3/5 cosine theta d theta. Okay, this guy is 9/25 sine squared. I'll just leave this guy alone as 3/5 cosine. Well, let's try and skip a couple of lines here. I don't know if I can do that without confusing you. Would you agree that's 9/25? Right? 3/5 is 9/25 sine squared. Isn't 25 9/25 minus 9 sine squareds? What's 9 take away 9 sine squareds? 9 cos squareds. What's the square root of 9 cos squareds? 3 cosine. Are you happy about all that being done in my head and why it ends up being 3 cosine? I mean, you can fill in the gaps yourself. So cosine's going to kill cosine. I got this guy, and I got a 3. Well, that 3 can cancel out with this 3, and that can join that. So I believe you get 9 1/25 sine squared theta d theta. Are you happy about the value of the fraction, why it ends up being a 9 over 1/25? I don't think this should be an issue. I know the fractions are really ugly. But what can I turn sine squared into? Because we've seen this today, or at least some similar. What can I change sine squared theta into?
1/2 times 1 take away 2 theta.
That guy, right? And this guy just adds to the misery. So let's just pull the whole thing out. I'm just pulling that out with the 2, so it's now 250. That makes this a little bit cleaner. So what do I get? I get 9 over 250 theta, take away 1/2 of the sine of 2 theta. So that's kind of where we are right now. Now the fella that I'm going to use, I'm rewriting 3/5 like that. If you do a little cross multiply, you get that. And then if you isolate the sine theta, you get that. Now you could probably do that other ways, but I just want sine theta, right? Because that's going to build my right angle triangle. This is going to be an opposite. This is going to be my adjacent. And this is going to be my hypotenuse. And opposite over hypotenuse. So this guy here is 3. This guy here is 5x. And this guy here is 9 take away that guy squared, which is exactly what I was hoping to see, right? So I'll just rewrite this guy again. We need to find out what this looks like when you turn them back into x's. Well, I got most of what I need. I guess for some reason I've decided to go in red. If you use this fella, won't theta be the inverse sine of 5x over 3? So that's how you get thetas. It's the inverse sine of 5x over 3. Now we've done this negative 1/2 guy today, haven't we? You know, or at least a guy that looks like that fella. If you think about what the sine of 2 theta is, it's 2 sine theta times cosine theta. So negative 1/2 the sine of 2 theta is really just negative the sine of theta, cosine of theta. And in this case, the sine is that guy over 3. And the cosine is that guy over 3. which means you get negative 5/9 an x and a square root filler. I don't think I'm getting much out of this at all. It's this fella and this cancel, and this kind of cancel. Now, if it didn't have a limit of integration from 0 to 4/6, I'd just put plus c here. But now I'm going to have to do x equals 0 to x equals 0.6 and ... 5 minutes later. We good?
Would the 2 sine times cosine be plus instead of negative?
Well, I included the negative in my calculation, so no. If I just looked at that, this would have been positive, and then take it away. It's there. So you can choose not to do it negative, but remember to put it in at the end as a negative, or you can use up the negative and don't touch it. Okay, do you want to say hi before you go? Get attendance done. Anything else for the good of the party? Are we good?
I'm trying to figure out where the negative 150th came from real quick.
This fella?
Yes.
Right. Hopefully I did it correct. I took the 9/250, which is this guy, and I multiplied it by the 5/9 with that guy. And
Oh,
I
okay. And you
cancelled them
cross-
out and simplified them down, and that's the 150 part.
Okay, cool. All right.